Engineering College with an outstanding placement record offers BTech, BBA, BCA, MBA, MCA, MTech, Cybersecurity, Data Science and Diploma courses.
Good morning and welcome to the webinar session on Pipeline Project Design Challenges. Today we have with us our guest speaker, Mr. Shekhar Banerjee. Shekhar Banerjee is a Jadavpur University alumnus. He lives in Alberta, Canada. Last 35 years, he has worked in design, manufacturing, and project construction in various countries like India, Canada, Saudi Arabia, and USA. He feels proud to mention that at least 10 Indian warships are carrying marine pumps, which are designed by him. He later became a specialist in designing pumping systems for petroleum companies like Shell, Petro-Canada, Sinopec, and many more. Last 6 years, he was constructing a refinery in Saudi Arabia. He is now retired and visiting India. Well, friends, without further ado, let us now move to the webinar, Pipeline Project Design Challenges. Please note that we shall be taking questions mentioned in the comment box during the webinar. Mr. Banerjee, now the audience is all yours.
Hello. Good morning, friends. How are you? Thanks for joining this presentation today, where the topic is Pipeline Project Design Challenges. Well, initially, my plan was to share my experience as principal mechanical engineer in a Canadian engineering company. So out of the 24 projects I've done, I chose a cross-country pipeline project of Saudi Arabia. But later, when I was preparing the presentation, I thought of adding a few sections which may be helpful to the final year students who are going to start their work life soon. So, okay, let's start now. The presentation, please. Let's have that presentation on the screen. Do you have the presentation on screen, please?
Sir, Shayan will be sharing just in a while, just a few seconds, I guess. He's there. He's going to share it.
Okay. Yeah, this is one, I guess the project, till the time Shayan comes up, let me tell you, when I shared this presentation, the presentation was initially meant for the people who are looking for a project job. A lot of mechanical engineers are required in the project. Now, when I was doing, then I thought of covering the other sections of mechanical engineers' first job, like some of you will go into maintenance, some of you will go into operation. So I tried to cover most of those. And let's start with the presentation now, and I'll come to all the points. So pipeline project design challenges, pure mechanical engineering technical thing. Shayan, next slide, please. Yeah, so today's topics are ABC of project business. Now, this section is important for those who are looking for project jobs, like say Mecon or DCPL or maybe Shubha's projects. Those are the common Indian companies, right? The second part will be the key divisions of oil companies. Now, these will be important for anybody who is aiming at ONGC, IOCL, or any Middle East type jobs. They'll like it. The third one is the Aramco cross-country pipeline project. Well, this is the core topics. I'd like to tell you about how we do a global standard mega project. Mega project means about $1 billion project. And the last topics will be the engineer cycling engineering. Now, this would be another very interesting topics. Just wait till the end because I don't like to really elaborate on this now. Next slide, please. The key phases of project business. Well, there is a slide before that. One second. Yeah. The key phases of project business. Now, project business, how a project is conceptualized. Now, let's imagine that our chief minister talks to the railway board and says that she likes to extend the metro railway across Kolkata. Now, when the railway board just looks at it and say, okay, let's study this one. That is called absolute conceptual area, which we normally call it as FEL 0. Now, from there, FEL means front-end loading of a project. So FEL 1 becomes the phase 1 of the front-end loading or the project business first step. What do we do here? We create a business report, and we don't do much of engineering here. We do costing from the past projects. We focus on the return on investment. So it's basically a commercial exercise. And we look at the legal obstacles, whether the project will be stopped at midway or not. All the risk involved in it are normally done by in-house resources. So it's a pure business case, little or no engineering involved, prorated costing, return on investment type thing. They don't hire an engineer for this type of project. Some finance guy will basically do that. The report will then go to the decision maker, say the railway minister or the government of West Bengal, for consent. And then we enter if they give the consent, we enter the next phase of the project, which is FEL 2. Next, yeah. Now, FEL 2 is sometimes we call it DBSP, or design-based scoping paper. It defines the scope of work, execution plan, risk studies, and it does a plus minus 40% costing. Here they have very experienced consultant, people who have actually done the job many times. Main task here is creating a document describing a general scope of work with a reasonable cost estimate, and this report, probably we make it in 2.5 to 3 months, goes to the decision maker again. But this time, it is for the budget allotment. Next slide, please. FEL 3. So we enter the third phase of the project. We very often call this one as FEED, a front-end engineering design document. This is where we need a lot of engineers, senior and junior. You will try to complete as much as engineering possible, but without moving a brick. Then you will write a scope of work with all the specifications, 2D, 3D design, equipment list, etc. This document will go to construction company for bidding. So the construction company will get it as a bid document, and they'll give the price based on this paper. Next slide, please. FEL 4. FEL 4 is execution. This is a final engineering done by the construction companies. So here we need a lot of engineers. Some of you folks, people who are in the final year of engineering college, will get an opportunity to work here first. Here you will detail out every nut and bolt, You'll place order for all equipment and pipes and construction items required. And you will inspect those and then deliver it to the construction crew. At the end of the construction, you will demonstrate the safety and performance during commissioning. Also, you will write the operating manual for the operators. So that is a very challenging job which your senior engineers will help you in writing. But finally, these have to be delivered in FEL 4 stage. right? So that is basically the section 1 of my project. Now, next I'm trying to introduce you to the oil companies. How do they operate? Now, in an oil company, see, oil is not produced as we put it in our car. We get crude oil from earth. Now, there are various divisions of an oil company. We have upstream, midstream, and downstream. Now, let's start with the first one, upstream. Now, when you're looking at the picture, you probably know that what is it? ONGC has similar offshore oil rig. We extract oil hydrocarbon from the ground, right? But it really does not come out in very pure form. Gas, oil, and water, everything comes out together. Now in that upstream area, we first do the drilling, and under pressure, the whole fluid comes out. Then we put it into a gas oil separator, which is a very large horizontal vessel. And it is also called a three-phase separator. Why? Because the extracted fluid settles in there, are separated into 3 different phases. All the gases, they bubble out through the top hole and taken out, because that's transported through a compressor. Water and mud, they settle down at the bottom and thrown out after a certain amount of treatment. And the crude oil, which stays at the middle. So we take the crude oil out and we pump it to the next phase. So drilling of hydrocarbon, separating the fluid, and finally, at this phase, when the oil well gets old, that it does not generate pressure out of its own, what do we do? There is still a lot of amount, about 30% of the oil is still there in the well. So here, like for the one in the picture, here what they do, they put another, they make another hole and they inject seawater into the well. Since crude is lighter, crude floats up and comes out. So we take the last 30% oil by rejuvenating or by re-injection. That's also our upstream operation. Next slide, please. Next is midstream. The midstream is basically the transportation of oil and gas from upstream area, that's a well area, to the refinery area. It's mostly a pipeline, a long pipeline, probably hundreds of kilometers long. But before we transport it, we put it into pipeline, we need to know, is it too sour? Now, what is sour? Sour means that if there is a lot of carbon dioxide and sulfur dioxide in the oil, then it will corrode the carboxyl pipeline. So we have to take out certain amount of carbon dioxide and sulfur dioxide, if it's present, from the oil. So upstream will do that too, or midstream will do that. So we extract certain amount of gases and sour out of it, which we call sweetening of the crude. And today's topics is basically one of these midstream projects. Next slide, please. And the last one, last division of the whole process is downstream. Now, downstream is where we get all sorts of finished products like diesel, petrol, bitumen, lube oil, LPG, from crude and gas. Now, these needs a huge process plant. You know, you may heard some familiar names like hydrocracking, distillation, refining, blending. So hydrocarbon comes in every form. It has to be broken down and it has to be graded. So through hydrocracking and distillation, we get different densities and different grades of the product. Then we start blending it. Now we get something like very hard like bitumen, then slightly lighter like lube oil, then we get slightly more lighter like heavy oil, then comes diesel, which is lighter, then the lightest is probably gasoline, which goes into our car engine. And then we get gas also. So gas has to be refined and made put into LPG or other type of industrial gases. And then these things are blended based on the customer's requirement, like probably Europe needs a different type of oil, India needs a different type of oil, Saudi Arabia, they blend it that way to the customer's choice and sends it. Everything is done in the downstream section. Now that is all about a division of an oil company. Now we'll move to the real project which I have done, and let me share that experience. Next slide, please. Now, cross-country crude pipeline. If you look at this map, you may pretty well understand. Can you enlarge the presentation, please? Can you go to PPT display, please? Shah? Okay. Okay, let's look for the timing. Let's look at this one. You can see the pipeline, cross-country pipeline. Now, Saudi Arabia is on the top left corner. From there, the pipeline goes inside the country as well as outside, like Iraq, Yemen, Qatar, UAE, everywhere. These are massive, means massive in terms of the length of it, 1,000 kilometer, 500 kilometer long. So each of the pipeline is also a more than $1 billion project. What I have been given to do is a 640 kilometer, 46-inch pipeline in Saudi Arabia. So, and that pipeline, it was a FAIL 3 type project. There, the pipeline, they said that they need an intermediate pumping station, and they wanted us to design the maintenance and monitoring tools. The total budget was a little over 1 billion, a little less than 1 billion, basically, 900 something million dollars. Next slide, please. Now, it was a FAIL 3 task. You remember I talked about FAIL 3, right? FAIL 3 is also called a design-based scoping paper. The client gave us the FAIL 2 document. They gave us the liquid details which go through the pipeline, from which we got the friction loss in the pipe, right? That's pretty easy. Anybody can do that. Now, they also told us the pipeline thickness. So what is the maximum pressure of the pipe can take? They told that the pressure cannot take more, cannot be more than 50 bar, or 50 bar is a design pressure. Our normal pressure will probably be 45. So we checked that whether in 50 bar or 45 bar pressure, whether the first pump can push the whole fluid to the end. No, it cannot. So we have to have another pumping station somewhere midway. So we studied the geography of the whole landscape, and then we determined that where the pressure, where the second pumping station should be. So the pressure is good enough to come there, and the pressure generated in the intermediate pumping station will also be good enough to take it to the end. So we found the best location, and we also found, on a large pipeline, you'll find many surge points. So we also designed those surge stations, which is just to take out the water hammer factor, which we'll probably talk in some other presentation. Right now, we'll focus on making the pump station for you, which is a mechanical engineering challenge. Next slide, please. Now, as mechanical engineer, let's see what are the main challenges here. The pipeline will run through desert. The location of the pump station will be hundreds of miles away from the nearest power grid. So how should we run the pumps? Well, we decided to tap a little crude out of the pipeline and distill it out. Like when the crude oil, as I said before, the crude oil comes, we have the technology to separate it to diesel, petrol, bitumen, etc. So we'll take out the lighter part, which is basically diesel, and the rest of it will again be re-injected into the pipeline, so it will be carried away. That diesel will be our source of energy. That's our fuel. We'll run the turbine with diesel. So we engaged a few chemical engineers to design a very small distillery, a mini distillery there, and decided to run all our pumps with gas turbine. Next slide, please. So the next challenge, again, as I said, the pump is at the middle of a desert. You really cannot do any major repair. Both gas turbine and pumps are maintenance prone items. If there is a major failure, it cannot be done at site. So, and there is no nearby town. So all maintenance items have to be dismantled and taken into a big city, right? Then when we like to dismantle, at what size should I dismantle? We don't have the technology there at the site to dismantle it to nuts and bolts. And we should not do that also because we cannot put it back. Only operation people are mostly stationed there, very few maintenance guys. So we decided to have a plug and play type component equipment. So but the equipment are huge. Like, let's give you an assumption that total pumping power is 10 megawatt. So Aramco decided to take it through flight, all the major components. So they provided us a cargo hold dimension of their Boeing 737. They have about 6 Boeing 737 for their own use. A big oil company is not uncommon for big oil companies to have their own helicopters and planes. So whenever they told us that if you propose us a pump and a gas turbine, you have to study how their equipment can be split into the dimension of that cargo hold. And again, when it's repaired and brought back, how it will be assembled at site. You have to teach us that. So whenever it's not as easy as just selecting a pump, we have to see that the components or the whole equipment itself fits into the cargo hold and can go back to the repair station. Next slide, please. Next slide, please. Yeah. Now here, I wanted to give you an idea how a cargo employee flight looks like. Now this is a Boeing plane which carries both employee and cargo. This one is not for Aramco. I could not take an Aramco plane's picture because of the security reason. So I gave it a stock photo here. But all of them looks like this. Now this hole, if you look at the cargo hole here, that's of interest to me. So we laid a runway at the side of the pump house, and this cargo hole dimension was the key for us to select a pump and compressor. How those can be dismantled, up to what we have to dismantle it to load it to this plane. When you as mechanical engineer have to really understand the components of big machines and how those can go out. Next slide, please. Next slide, Shan. Yeah. The third challenge we had is the ambient temperature in Saudi Arabia, especially in the middle of the desert, can reach 60 degrees centigrade. Now, gas turbines are made in standard rating, and those ratings are called ISO rating. ISO rating is where the gas turbine is tested at 15 degrees centigrade and sea level. So the performance is stamped based on that. But here will not get that performance because for every 10 degrees centigrade, the gas turbine loses about 6 or 7% of the ISO rating. So if it is a, say, 5 megawatt gas turbine, it will probably be about 4.6 or something, or 4.8. And then if another 10 degree increases, then it will probably be 4.5. So we have to derate every gas turbine to about 70% of the ISO rating. And the gas turbine and the pump combination, the whole scheme needs a very large lube oil cooler. Now, normally we do lube oil cooling by water, but in desert there is no water, right? So everything is air cooled. And lube oil has to be brought down to 90 degrees centigrade, right? Now at 60 degrees centigrade air temperature, we have to reduce the hot oil to 45 to that temperature, 60 degree, and then it will go up to the bearing and it will go to 90 degree and come back, and it will go. It has to be brought down to 60 degree immediately. So we have to have a very large lube oil. Basically, there are double-sized lube oil coolers that are installed. So we calculated a whole project based on these sizes of equipment. Next slide, please. Now, an engineering consultant, they have to have certain tools. You may not, I mean, I'm talking to the students here. You may not see those tools in engineering college, but once you go to the industry, especially in the project business, you will find all of them. Like engineering software, I'll talk later. And you probably have to be extremely familiar with gas turbines or pump stations, especially, I mean, when they selected us, they selected based on these, that we have the proper engineering software, we have familiarity of gas turbines and the pumps, probably Sulzara, Floza, who are the world leaders with this type of large API pumps. And you must have a tie-up with specialists like surge control or smart pig. Smart pig is something which I'll talk about later. I'll show you a picture of it. Those are the tools an engineering consultant must have. So the company I was working for is SNC Lavalin. They have all of them. So we have been selected for doing this job, and we used it extensively. Next slide, please. On pipeline, we talked about the pipeline maintenance, right? You know how a pipeline maintenance is done. The pipeline, this is the tool which is called a smart pig. This cleans a pipeline, but it not only cleans that, it also does all quality inspection together. How? We basically need to know whether the pipeline is corroded or not after some time, right? Within in a couple of years, the pipe starts corroding from inside as well as from outside. So, but we need to know in a 640 kilometer pipeline where it is corroded and how we can plan the maintenance. So this smart rig is inserted into the pipe. How? When you're pumping the fluid, we just stop it momentarily. Then we push one of these equipment into the pipe. There's a small hole to do this job. And then we start pumping again. The fluid at the back pushes it to the fluid to the front, and it keeps on rolling. When it goes, you can see the odometers at the back. That odometer rotates, it rolls on the pipeline wall, and it starts counting the distance, how far it has traveled. You can see the transducers and the battery system. The transducers and battery system, they have the ultrasonographic probes on it. That probes that measures the thickness of the pipe throughout its journey, and it records it. When it goes to the end, somebody takes it out, it takes out the chip from it, it puts it into a computer, and we get a very clear picture about the thickness or the health of the pipeline. Next slide, please. Yeah, these are the ultrasonographic probes. These probes, you can see, it's sending ultrasonographic sound to the wall. And when it comes back, it can see the outer wall and the inner wall. It basically takes a very clear picture. The picture, the graph you can see at the bottom, that the wall thickness is counted that way. Actually, it is currently in present scenario, they can really can distinguish between the inner wall corrosion and the outer wall corrosion, and they can tell us exactly where it has happened. Based on the previous in previous slide, I have shown you the odometer, which is counting the distance. Now, with this, the pipeline maintenance engineer can plan that whether he has to do a spot welding or he has to do a reinforcement, or a major section of the pipeline has to be cut for which you have to stop the pumps and drain it out. There are various ways of maintaining a pipeline. So that can be planned well in advance. It's a continuous monitoring tool. It is normally done once or twice in a day. Okay, so that's mostly in short how our engineering company does a pipeline project. Now, since this is meant for an engineering college, this presentation, let's look at how our young engineers, they can find themselves in such engineering companies or the project companies, and how they can help designing a project like this or other things. Next slide, please. Yeah. So this is the topics which I like to talk about now. The engineers are killing engineering. How? Well, they are not literally killing, but they are killing the engineering jobs. The engineering jobs which, when we passed out 35 years back, we understood as engineering job. Like all formulas, whatever it's written in our books has already been converted to a software. Big IT companies have hired thousands of engineers to create programs where you just put the raw data and you get the results instantaneously. Our old practice was calculating everything like vessel thickness or pressure, temperature, etc. Doing the design check by a senior engineer. Everything is obsolete now. Let me tell you what everything is done by software. Let me tell you what are the popular softwares which are being used by these engineering companies. Next slide, please. Now, one of the very popular, probably the most popular process simulation is done by Aspen HYSYS. Aspen is a company's name. The software's name is HYSYS. Now, this is for chemical engineers. It's process simulation software. It does everything. Honestly, if you are designing say power station, a boiler, okay, let me put it this way. That if you're designing a chemical process unit, like a refinery, you put your input that the whole composition of the fluid which is going in, and you tell how what you like to take out from a, say, hydrocracker. It will tell you exactly what will be the size, what will be the PNID diagram, everything, what you need to make it happen. From process point of view, it does PNID, it does heat mass balance, it does safety review, that in various what-if situation, if safety is compromised or there is some extra heat somewhere or a section fails, then how we can contain the damage. Everything can be done by HYSYS, straight on your computer. For mechanical engineers, Compress is a very important software. It does ASME 8 pressure vessel design. Now, I'm not sure whether you are familiar with ASME 8, but if you are, that's the key document, probably the only document that all engineers in the world follows for designing a pressure vessel. Compress has converted the whole book of ASME Section 8, a massive book, to software. And you just put your internal pressure, your temperature, your liquid, the inlet-outlet pipeline, and probably maybe the size, the outer dimension of the vessel, and they'll design it entirely for you. They'll give you a drawing for you. There is a similar software for ETAC, which is for electrical engineers, which does a network modeling, does a simulation. If there is a power failure, how you can prevent it, how the voltage, I mean, if people in West Bengal knows a little bit of load shedding. ETAP can design and predict everything. And they can also produce a single line diagram based on the load list you put it into or your requirement you put it. And they can give you an Excel sheet giving you the load list, how the load on different phases or can be distributed so that the load becomes, there's no phase imbalance, everything. Next slide, please. Okay. Some of your mechanical engineers will also be a piping engineer in future. Now, in piping, we have to calculate a pipe stress analysis. Pipe stress is the pipe expands when the temperature fluctuates in it, especially when it is more than 150 degrees C. The pipe stress becomes critical, and there are pipe failure. I mean, some people might remember that there used to be a lot of pipe failure in boilers for our power plant. CISO2 is a software which does the pipe stress analysis in the design stage itself. There is a software called Smart Plant. Now, Smart Plant is basically, you probably know 3D, CAD 3D. Smart Plant is similar. It does a 3D modeling, but it can also create the PNID. So it will tell you how many valves and how many the joints and what are the piping spec and how many flanges are there and everything. They can give you a PNID printout for this, based on which you make the plant. So every engineering and consulting company have either licensed or pirated copy of it. With this software, they can build a virtual project, more like a video game. So I found that engineering, which I learned in classroom, is completely obsolete now. So what should we do now? Next slide, please. Okay, let's see. What does an employer expect these days out of a junior engineer? They expect familiarity with a range of products, like how they work, the ranges, and cost. Yes, cost. Engineers, when they provide the engineering solution, they have to have a very clear idea then how much it will cost to the customer, right? Like you go to anybody, you buy a cell phone, a mobile phone, he explains you a feature, you definitely ask, okay, what's the price of this one and what's the price of that one? So you have to present options and with a cost. Now, young engineers must have that idea. But more than that, young engineers must be confident and must have, I can do anything attitude, The employer also looks at his communication skill. Can he observe everything? Can he make a short, concise report? Can he communicate with the field guys effectively? No stories. Absolutely data-based reporting. We look at it very thoroughly, that how he communicates. And finally, they'll look at how well you integrate with the existing team. During interview, they will think about that only, that whether he fits into our family or not. He may be a great guy, but does he fit in our family? I'm giving you an example that like companies like Bridge and Roof, they used to come to our college and they used to hire people who are not the top 10 because they don't fit well into their companies. But Hindustan Lever used to hire from top 10. So there are different cultures in different families. Here, an employer looks at a junior engineer during interview and he wants to really assess that, does he fit into our family? Now, out of those 4 things I told you, familiarity with the range of products, I can do anything attitude, communication, and how you fit into the family, how you integrate there. Your engineering college will only give you the first one. Rest of it has to come from your inside, students. Please remember, confidence, communication, and integrating with a team, the ability to go in and be friendly with everybody is your own skill. You have to have that. Next slide, please. For every engineering task, we use common material, right? We don't design everything. We use common material available in the market. Now, my question is, how much our students are familiar with popular products? And here I tried to name only the Indian companies, like say KSB or Kirloskar pumps. These companies make a wide range of pumps. Are you familiar with their products? Diesel engine. Diesel engine, you also need a diesel generator very often. Cummins is probably the Indian leader for diesel engine. Air compressors, you'll find Atlas Copco. In air compressor, it's basically not only the compressor, it's a compressor dryer unit. So, are you familiar with that Atlas Copco products? Air compressor and dryer unit. Okay, gearbox from Elliott. Elliott is a, Elliott or Allenbury. Allenbury is somewhere near Hazra. I mean, it was near Hazra. I don't know whether they are still there or not. Are you familiar with their products? Larsen Toubro valves. Larsen Toubro is probably the Indian leader on valves. Do you know how many types of valves they make? Gate, glow, check, butterfly. It's very important to be familiar with these products. Next slide, please. I also want you, the mechanical engineers, to know a little bit of the software, at least how to switch it on. Like CAD 3D, probably, I hope most of the engineering colleges teach how to do CAD 3D. Similarly, Compress or Caesar 2. You need a basic familiarity. I'm sorry, I'm out of this country for many, many years, so I do not know how things have developed in engineering colleges. But I just want to make sure that the teachers included at least a little bit of this software. How does it look like? What does it do? You need not master it here. You'll master it if you go to project business anyway. But the popular software is the name of it. Okay. And the third one is very important. The commonly used industry-specific standards for this type of equipment. Do we tell our students that which standard, or we call coded here, we used and where. Here is a small list of as example only. But let me give you here an example why it is required. Maybe you are just questioning internally that why do I need to know API 610 or what is ASME 8 or what's SAGMA or NFP, and is it possible to know much about it? Now let me tell you what are usefulness. Imagine that you joined a company, a small company, who wants to make a building. So in a new building, they will probably, for making a new building, they will probably employ a number of civil engineers. They'll probably have one electrical engineer and one mechanical engineer. And you are the mechanical engineer there, okay? They have to install a few pumps here. One pump for, say, for drinking water, one pump for, say, sanitation, and one pump for the firefighting. And if, say, for instance, there is what should I say, petrol filling station of, say, State Transport Corporation. Okay, let's imagine that. Then you have to have a fueling station. There is a pump there also. Not the pump which you see, which is basically a metering unit. That's not the pump. The pump is somewhere not visible inside the ground. So what type of pump you require for all these things? You go to the market to buy a pump of your specification for drinking water and sanitation. Is it the same pump? No, probably not. For drinking water, you may need a stainless steel pump because there is a code for drinking water system. For sanitation, you probably can use a cast steel pumps, or maybe a cast iron pump also will work. If you are putting a oil filling station, then you need a submersible pump, very small type, very industry specific, or API 610 pump. And for firefighting, again, fire is fought by water, right? So can you take any pump from the market? No, you cannot. The building or fire department will not give you a license for that. That pump has to be approved by NFPA 20. That's the same single stage cast iron pump. It has to meet a few additional requirements of NFPA 20. So do you know what is NFPA, National Fire Protection Association's code? We just need to know the name, nothing more than that. But you need to have a little introduction, or even if you don't have, if you have that introduction and you go to an interview board and you say, I know this difference. Imagine what difference will you make in that interview room. So it's important that you should know, you should have some familiarity that commonly used codes. Okay. So that's why I just want to stress you out, students, even for your academic interest, you find out which type of codes or discuss with your peers and seniors, what type of codes are used for which industry. Next slide, please. Next slide, please. Yeah. Now, looking at the job market today, most of our students will go to operation. Some of you will go to maintenance. Some of you will go to projects, and some to sales. Probably these are probably the four major streams, right? Now, not every mechanical equipment uses instruments. The mechanical equipment does not come just like that. It comes with instruments, some electrical items, civil items, and metallurgical items. Now, can we make familiar with those items, please? Now, say for instance, instruments. If you buy, again, a pump set or a diesel generator, you probably not diesel generator, but probably for pump set. You have to have a pressure transmitter, a temperature switch, a flow meter, or a hydration reading if it's a larger, more complicated type pump. The pump will come on the same base plate installed with a motor. So you need to know what type of motor you have to buy, because you are buying it, right? You are ordering that equipment. You are going to inspect the whole item. Your electrical friend will not go for this. You have to learn. Then when it comes, who will do the grouting? The civil engineer will probably engage some people to do the casting, etc. The casting is sitting there. After the grouting, you have to check that grouting, that it's absorbing whole of its vibration, right? And if the pump somehow malfunctions or does a leakage or something, you have to do the NDT. NDT is non-destructive testing, like dye painting or ultrasonography, or for complicated item radiography. Now, do you know what are those? How to do the quality check of your equipment? These are so very important, friends, so very important when you go to the industry and stand the man alone and get a job done. It's so very important to know from other streams also, especially instrumentations, a little bit of electrical, a little bit of civil, and a little bit of metal is related to basically quality check of your own equipment. Okay, I'll start asking you folks a few questions before you ask me. Next slide, please. Can anybody tell me what is this? Now, probably anybody who is looking into a job in operation might know or should know. What is this? Well, this is a turbine flow meter. I'm not sure if you can see it out here. You can see a small fan blade here. Now, this is such a small piece of equipment. You just install it. You cut a pipe. Somebody told you, okay, I need the flow in this pipeline. You cut a pipe, you weld two flanges, you insert this one, and you bolt it up again. And the impeller starts spinning, right? When the flow of liquid goes to that. And it creates, you can see a probe at the top. The probe gives a pulse that how many impellers have crossed it. And it gives you a 99%, 99.5% probably accurate reading digitally on the screen. You can see on the top. These are just two components to be fitted together. Now, my question is, are you familiar with this, or are you still working with Venturi meter in your college? Okay, let's try the next one. Next slide. So next slide, please. Okay, this slide is for maintenance guy. The previous one was for the guys who will go in operation. This is for maintenance guy. Anybody who is looking for a job in maintenance may look at it very carefully. This is a vibration reading of a pump. Now, when I do vibration reading, we just do not see the total vibration. We break it out into various frequencies. Like in a music concert, you can really distinguish between a tabla and a sitar, right? Based on the frequency. We also do that. We divide it based on frequency. You can see at the bottom, 0, 5, 10, 15, 20 frequency in order. This 5 means the 5 times of the RPM of the pump. So if it is, say the pump is spinning at 1500 RPM, this frequency is 7000. 10 is like that, 15,000. We can get a complete frequency reading here. Based on the complete frequency reading, now we start finding out which one is going wrong. Now, so for instance, for this reading, you can see the first one is for imbalance and misalignment between 1 and 2, basically, for imbalance and misalignment. We get a high frequency very often for in the range of 5 for looseness. And then the bearing issues. Now, bearing has 7 different balls, right? And there are normally 2 or 3 bearings in a shaft. All the bearings create a little bit of sound. The sound, all those sounds come here. We can, again, if we see the very high pitch here at 20 or 25, you probably think of changing bearing. So just by looking at it, a maintenance engineer can say that this equipment is fine. There might be a looseness of one of the bolts, so we'll check the bolts here. Imagine how you can impress your boss just by looking at it. If you can do it on your first month, they will love you, right? So somebody looking a job into a maintenance field might learn casually also that how to read similar graph. Next slide, please. Next slide, please. Yeah. Now, what is this? Now, I'll pause and let a student to answer, not a teacher. A student, please answer. Try to answer. If it is wrong, also answer. Okay, seems some of you got it right. Yes, it's a gas turbine. A gas turbine. Now, you probably have not seen it this way. All of you probably have seen gas turbines, right? Where? Because all the planes have gas turbines running on its wing. No, but you have not seen it this way because it has been dismantled here, and it's much larger than a aircraft type engine. It's a stationary engine installed on a base plate. You can see that how it is installed and how the inside looks like. But at least if you know how the inside looks like of a gas turbine, just a picture, maybe a YouTube video, that will be good enough for you to answer something or impress to your potential hiring company or the interviewers. Next slide, please. Next slide, please. Yeah. Now you'll all be hired as an engineering officer, right? Initially, you'll probably be an engineering trainee, and then you'll be promoted to engineering officer in a year. Now you're supposed to supervise the workers. Now, how can you be effective if the workers know more than you? So if you get an interview, now manufacturing is not exactly the strength of West Bengal, but if you get an interview in a manufacturing company, will you be able to tell them how a MIG welding is done or a MIG welding machine is set? Or how to dismantle, if you are going into maintenance, how to dismantle bearing from shaft with a bearing puller? Or how to apply Loctite to open a rusted out casing? Or do you know how a CNC programming done on a CNC machine? Or do you know anything about jig design? Or have you ever tried robotics? Some engineering college I know here in West Bengal, they have introduced robotics. So, but whether it is introduced, do you have interest in learning this? CNC programming, jig design, robotics, MIG welding, TIG welding, gaslighting and rod welding is still popular, but no, probably not in the manufacturing sector. The manufacturing sector today, they have gone for MIG welding. And maintenance, changing a bearing, changing a shaft sleeve, the wear casing ring. You probably need to know how to do that. You don't need to do it. The worker will do that, but you have to tell them how to do it. So as an officer, as an engineer, I expect you to have a little bit of knowledge on this. Now, I'd like to really, at some point of time, I'd like to hear a big yes on these questions from you folks, because globally, and let me tell you, here I'm sharing a story on my own experience as a hiring manager for mechanical engineers in Canada. Believe me, and I'm repeating this thing, if in Canada also, we do not get good, fresh engineers. Now, that does not mean that the engineering students are bad. They study very hard. They all know all theories. They probably can give a lecture for an hour on enthalpy versus entropy and bending moment and so on and so forth. But if I tell them to just open a rusted pump and put it right, they don't know what to do. From my personal experience, I had an engineer of engineering of Indian descent who was working with Boeing on hydraulics, and he was involved into Dreamliner. He was in that team. Then he wanted to settle down in Canada. He came to Canada, living with a Boeing job, and he was hired by my company. He's an aerofoil design engineer, so he was given to me as a hydraulic group, rotating equipment group. And I honestly do not know what to do with him. Now, good that he was a smart guy. He immediately learned the vibration, which is a major issue for us everywhere in industry, and become a specialist in that. But I really like to stress that there is a major difference between what you are being taught or all the theories you are learning to the practicality at the field, making the job happen as mechanical engineer. And you students have to bridge the gap. You have many tools. You have YouTube video, thousands of them, fantastic videos. Watch them at your free time. Try to ask questions to your senior, show interest, and then you learn it. Along with your formulas and everything you require for good number. I'm not against that. But please, you learn it yourself to make a difference and getting a job faster. Okay? Well, we came to the end. Remember, a mechanical engineer is a complete engineer. When I interview somebody, I want to see that I want to check the engineer's familiarity, the attitude, roll of the sleeve, the communication ability, and finally prove that you are the guy, you are the complete engineer. Okay, questions?
Thank you, Mr. Shekhar Banerjee. Thank you for such a wonderful speech. Now, before going into the questionnaire, I would like to say some things. Firstly, I hope that the audience here has benefited highly from your talk and has learned a lot of new aspects, mainly about how does working in an industry feel like, what are the challenges to be faced, what are the things, apart from regular academics, which a student should learn in order to get inside the industry, what are the instruments that are used in the industry, and last but not the least, what are the qualities which set aside a mechanical engineer from his or her competitors. Now, I would like to introduce to you all a person who is probably one of the most familiar faces of Netaji Subhash Engineering College, Professor Debashish Burman.
Hello everyone.
Welcome, sir.
Yeah.
Yes, sir.
So
Now I would like to
I hope.
say some things. Uh, just a moment, sir. I
Okay.
would like to say some
Please
things
carry.
about him. That is, Professor Devashish Burman was born and brought up in Kolkata and passed his HS examination from Hindu school. He obtained his BE Mechanical Engineering degree from Jadavpur University in 1983, after which he joined the industry and worked in different capacities in a couple of PSUs. In the beginning of 2001, he decided to switch to academia and joined Netaji Subhash Engineering College. He is presently serving as the HOD of Mechanical Engineering Department and chairs a number of other committees in NSCC. His industrial experience is more than 17 years and academic experience is more than 20 years till date. He did his PhD from Jadavpur University while serving Netaji Subhash Engineering College and has a couple of international papers and conference papers to his credit. His research area is thermofluidic science and he teaches different subjects in NSCC. He possesses a natural flair for basic mathematics and physics, which are aptly visible during his teaching learning process. Now we'll be taking up some of the questions left by the audience in the comment box. Now, before beginning, I would like to mention that due to time restriction, we would be taking only 3 to 4 questions. Mr. Shekhar Banerjee, the first question was from a student called Harshdeep. Now, he asks a question which says that, what are the problems you faced while handling the pipeline project? For example, how did you handle the sandstorm and how did you deal with it?
Okay. It's easy. When a sandstorm occurs in desert, the pipeline is normally not exposed. After some time, it goes inside the sand. When it goes inside the sand, the sandstorm doesn't affect it, right? So you basically make two walls. You dig a channel there, you put the pipeline, and then you put sand on the top of it. The sandstorm blows away. That's and we have to make fencing so that there is no authorized crossing or there is no truck rolls on the pipe. So we do, but that is a very simple, again, a very common sense thing that you dig it inside the sand, then there is no sandstorm. Next.
Okay, sir. The next question is from Mr. Amit Kumar Das. Actually, he wants to know what are the qualities he needs to have in order to become a CNC programmer, or rather, I should say a CNC engineer.
A CNC engineer. Okay, CNC. I don't know whether he is familiar with the CNC machine or not. The CNC machine programming is a different set of skills. Is that in engineering college? Today's curriculum, CNC programming, is it there?
Yes, sir. It is there now in the final year of mechanical engineering.
Good. Excellent. Superb. So a multi-turret lathe or a vertical boring machine or something. How to program it? Start with a very simple one. Probably, I'm sure that when they are teaching this one, they have already taught you at least a single tool type machine. Then learn something to do with a multi-tool. Should be, I mean, you must be having a professor teaching that. He should be able to do that. I'm happy that it is there. In our time, it was not there. So I'm carrying that impression. But good that it is there. I'm so happy, honestly. It's not there in Canadian Engineering College. My son went for graduation into Calgary University. It's not there. So you guys are teaching it. Fine, you are ahead. Good. What else?
So the next question is from Mr. Arindam Das. Actually, he wants to ask how can he become qualified enough to serve as a junior maintenance engineer in any industry?
Fine. This is one thing I like to take a little bit more time.
Yes, sure.
And we as the engineering college has to play a small role here. I'm sure that many industries donate you or send you their small machines, their cutouts for demonstration, etc. You must be having diesel engine cutouts, etc. How much junk do you get? Do you have junks, industrial junks, rejected pump? Do you have that in
Yes,
your
sir.
workshop? Okay.
Not
Go
exactly
ahead.
pump, but
Yes.
we have certain other components.
Okay, certain of a heat exchanger. Do you have a small heat exchanger there?
Yes, yes.
Okay, if you have a small heat exchanger, then student, he himself can do a hydro test, can find out where the leakages are. He probably, if he see a leakage, can he learn to do ultrasonography or DP test, not DP test here, it will be ultrasonography to find out which tube is corroded or leaking. Then does he know how to block it, the tube? Similarly for pump. Now, when you are getting an item, I'll imagine that it will be totally rusted. I'm basically a rotating equipment engineer. So let me bring that example to pump itself. That how to open a pump is probably the biggest test. Where to put a Loctite and how to open it without breaking. You need a certain amount of skill, a good hand to do it. Then open it, then see the bearing, use a bearing puller, take it out. I'm not talking of a hot bath because that might be risky for you when you're teaching a number of students. But you can take out the shaft sleeve, you can insert a shaft sleeve, you can put a Teflon coating on your nuts and reassemble it again and see run it. Take a vibration reading of it and see, set it right. Give them 7 days, give them a jump, which is basically the industry has thrown it away. Some of your students probably can give us, or maybe the industry can give, the rejected material which will be sold as scrap. Let's set it right. Even if we cannot set it right, that experience will build up a confidence in that guy that yes, I can do that. He will do it in the industry. He will be able to do that. Give them an opportunity in our workshop.
Okay,
Next.
sir. Okay, sir. The next question will be from an ex-student of ours, that is Ishan Das. So he would like to ask is, for the cross-country layouts, did you provide expansion loops, and please say the details. Means you would like to mention. You to mention the details.
Let me tell you, the cross country, on the map you said it's a seat straight. It does not go straight. It goes like this and this, it bypasses the major town just for fire hazard. And when you do that acts as a loop. And in a sand bed, when you put two walls, you keep enough gap so that the pipeline can expand or contract a little bit. So it allows a little bit of swinging inside the canal. And for his name is Mr. Das, right?
Yes, sir.
The student is for Mr. Das. Mr. Das, you know the thermal stress is normally becomes critical probably over 100 C. The pipeline carries a crude which is ambient temperature, and it also cools down the ambient. I mean, the pipeline in desert, the temperature can go down to 20 degrees and go up to 60 degrees. The crude is normally continuously flows and keeps it at a standard temperature. So normally for cross-country pipeline, that's not a concern. The little bit of concern can be taken by the space in the groove, and it is not a straight pipeline, so it can swing a bit. Next.
Yes, the next question is from Mr. Deep Bishwas. He likes to ask is, what are the softwares that what are the design types of what are the design softwares that a mechanical engineer should know in order to get a better job in the industry, or in order to be ready for a job in the industry?
Okay, on heat exchanger, be familiar with HTRI, and then I have talked about compress and scissor. Begin with that. Begin with compress. I think Professor Borman himself, he knows a lot about pressure vessels and welding, etc. He can suggest something here. But let's start with compress. And for HTRI, there are softwares. And for pump, if you want pump, there are softwares available issued by FlowSurf and Golds, which are web-based software. I created my own mini software for a quick selection consulting type job. If I get another presentation, I can talk about those softwares later. But your students right now can look at Compress and Caesar 2 and HTRI.
So the next question is from a student, that is, you have mentioned certain softwares in your presentation. How to become familiar with that, or how to learn about these softwares?
I'm
Okay,
sorry,
yes,
I'm probably losing the connection here. No, I'm back. Burman is back. Sean is back. Yes.
Yes, sir. I'm repeating the question. Yes. So you have mentioned certain softwares in your PowerPoint presentation. Now, from where do the students learn about them?
Okay. We can have. He's a mechanical engineer, right?
Yes, sir.
Okay.
He is actually a student of Jadavpur University.
Fine. So ask your professor. If they know about. I only mentioned 3 softwares to start with.
Yes.
One is a pump selection software, which is available in the internet. I think it's called Spectrum by FlowSurf. There is one from Golds. Find out the pump selection software. Google it of Golds and FlowSurf. You will find it. Number 1. Number 2 is for designing pressure vessels and tanks. Software, very primitive type softwares are freely available. Let's say Excel-based software are available on the internet. Google it, you will find that. But if you really want a real software, real industrial software, one of your friends can, I mean, for anybody, if you have one of the ex-student in industry, some of them should be able to do that. I'm really, in this forum, I'm not recommending getting a pirated copy, but some people have it.
Okay. Okay, sir. So that was our last question for the day. Now, I would request Professor Devashish Burman to come in and have a small discussion with the speaker. Over to you, sir.
Thank you, Shekhar, very much. As I know, but the audience do not know that Mr. Shekhar Banerjee is having a problem now in his family. I know this very well, and today he is to release his seriously ailing mother-in-law from the hospital. And in spite of all these things, for the last 1 month, actually, he is struggling, and his mother expired a few days back. But still, I'm telling that the commitment that he is having, that, as he said, he committed that he will have the webinar today. So I'm extremely thankful to him for keeping his commitment, and it is a learning aspect from us all, for us all, actually, for the students also, that whatever comes, whatever family problem comes, he is there for this webinar for almost 2 hours. And thank you very much, Shekhar, for these things. Now, at the end, I won't take much time, because I know that you have to go out for Fortis Hospital now after this webinar. Now, I'm very proud of you, that I am proud of like many other classmates, that you have achieved a lot in your career throughout, At the end of the career, you worked in Saudi Aramco, which is the largest oil refineries, which are largest oil refineries in the world. And now I ask you one or two short questions, like which I get from the students while teaching the fluid mechanics in the classes. Now I'm teaching fluid mechanics in the 4th semester.
Oh,
So
really?
in actual practices throughout the world, the industries do not employ the measuring instruments like venturimeter, like pitot tube. That is what is described in the books, all the books, even in the best books of the world, that is on fluid mechanics, like Fox and McDonald, Sengel. They still talk about all these instruments. But I know from you actually. Basically, I knew from you that yes, these instruments are not in use practically in any industry throughout the world. Now, if you kindly elaborate for a few minutes, that what are the instruments, devices actually used for like flow rate measurement, the velocity of flow, all these things that you.
Okay.
A few minutes.
Okay, quick. I'm sorry, I should have shown a slide, but here, verbally. You have to measure flow all the time and pressure in a pipe, right? If you have a filter in between, you need a differential pressure measurement. If you have a tank, you have a level measurement. So that's basically pressure, temperature, differential pressure, level. These are probably your input items. Is there anything else? Okay, I don't know, but maybe if it comes to my mind, something else, I'll come back to you. For all these items, there are sensors and there are switches. Switches are basically gives you on-off type, that it has exceeded and it has not exceeded, which is like analog signal. And there are sensors which gives you digital signal. Students must be familiar, at least by looking at it, they should know that this is a pressure sensor, this is a temperature sensor, this is a flow meter, and these are level transmitter. The level transmitter, now in our time, in a large tank, we used to have a float, like in large water tank, we used to have a float. When it is full, the flow comes down. No, it is full, oh, it has gone up, start the pump again. Today it's all gone. We put this small ultrasonographic probe there. We connect it to the pump through a switch, through a small DCS. The probe counts, okay, this is a level now, I got to start the pump. It starts the pump automatically. It's not manned operation that somebody goes, looks out, comes up, switch it on. No, it's all gone. So similarly, in a pipeline, we calculate if it's a pressure switch, it probably puts pump on off. But if it is a sensor, then it works much better way. Like it gives a high pressure signal. Before shutdown, it goes to alarm. It tells that, okay, there is an alarm, there is a blockage somewhere. So you might clean the blockage before you shut down the pump. And often, now these are the input signals. There are usefulness of output signals. Like if, say for instance, you have a filter, you have a twin filter, your flow, one filter is working now, the other filter is standby. Now this filter gets clogged. When it gets clogged, in a differential pressure switch or a differential pressure transmitter tells you that this is clogged. There is a three-way valve on both sides. It moves to the other side, and the fluid starts flowing continuously through the other one. And you get a signal, okay, somebody has to run to the field, clean this one probably in next 2 hours time. That is how you package a machine. A machine right now, not only a component, not only the whole casing, it is a package. Now packaging is a big subject. I think in mechanical engineering you can talk about that, but instrumentation has to be essentially taught to mechanical engineers. These are the basic instrumentation.
Okay.
One or two classes will be enough. What else?
No, okay, but I know this are really very big. I know that, but it is not possible now. One more thing, one more question I have in mind, that when the cross-country pipeline, suppose it is 1,000 kilometers long or something 500 kilometers long. Now, how frequently, what is the distance between two measuring stations means that measure pressure, the flow rate, and all these things? Do you have a control room for that at some place, maybe 1,000 kilometers away, or the separate stations are there in between throughout the pipeline?
Okay, in that presentation, I told that we have to first see that with the existing pressure of the pump, the pipe can take up to certain amount of pressure. Otherwise, the pipe becomes big, and the cost of the pipe becomes prohibitive. So the operator likes to keep the smallest thickness of the pipe. Generally, 50 bar, 40 bar is a very standard pressure. With that pressure and with the thickness or the viscosity of the liquid, you know how far it can go. And you know how many pump stations you have to make. It is easy. Each pump station is normally the monitoring station. That's same in Canada also, not only in Saudi Arabia. In Canada, we get the oil, which is thick oil, bitumen, basically, bitumen type oil, and we put some thinner in it so that it can be transported in the north side, and then we bring it back to the refinery, which is in Edmonton. For that's about 300 kilometer journey, we got to put two pipelines, and when we bring gas, we got to put probably about one compressor station in between. In that area, you make the monitoring station.
Yeah.
And the peak comes out at that point. The peak comes out. Their basically daily job is peak launching and peak receiving and cleaning it out and taking out the chip and sending it for reading. That's a daily job.
I could follow it. Thank you. Thank you. Another thing I like to ask you that you have already mentioned in your slides actually while presenting this lecture, that what are the qualities that is required by the budding mechanical engineers who are studying in third year, fourth year, second year. And what qualities, specific 3-4 qualities you have mentioned. I got that. I am really agree to that. Basic qualities I'm telling, because they cannot learn everything. They cannot learn everything in the 4 years of studies. Now I want to know from you one more thing. As a teacher of an engineering college, so you are an on-site engineer, you are an industry personnel for long years, maybe for 37, 38 years, and you are working almost in the same field, not exactly same, but it's a thermofluid science. Now I am also from the thermofluid science background. Now, I wish to know as a teacher that you can highlight on the topics, or you can highlight that in the classroom, that what are the things we should highlight in the classroom along with the syllabus, so that it is relevant. It is relevant for the student, to work as a thermofluid engineer in an industry, or they can feel better while sitting for the interview for such jobs or for consulting jobs.
Devoshi, do you have any ex-student gone to Thermax? Anybody working for Thermax? Any of your students?
Yes, there are some students here who is watching this Facebook live. Some students.
Fine. When they come to Calcutta, some of them may be in Calcutta because they are in field installing or something. Tell them to spend half an hour with the students. That is the best thing. That is what we call there in Canada. We call it professional networking. But here, the networking. I mean, let them come. Let them have coffee with them. Answer their questions. Maybe go to the classroom. Put a projector. Make a small slide. Bring a small piece of machine. They don't need to donate. They can just show a video of their site. You see, taking your students to the site at these during pandemic and otherwise also is expensive. You got to create bars, you got to give them PPE, etc. They can bring in the video, they can answer the questions. Bring your ex-students, bring the industry seniors to tell their stories. And anybody who is interested, this will not bring them us, but this will bring them future. So anybody interested on a Saturday or Sunday will come.
Okay. I got your point. I got your point very much. And
I mean, I cannot really answer in 5 minutes that what they should know. There's no solution because during the installation there is a different skill required. During the design there is a different skill required. During manufacturing another skill required. For manufacturing they have to be a master of welding. For design they probably have to know a lot of HTRS software and materials, etc. For installation is a completely different skill. So just being in thermodynamics or in hydraulics really does not mean anything.
Correct. So thank you very much, Shekhar. I think that we have crossed 90 minutes. Yeah, more than 90 minutes. So I won't take much time. I've already taken much time. But one thing is there that you have achieved a lot in your life, and you are settled in Canada now, and you'll be leaving for Canada in a few days' time. So I request you from the Netaji Subhash Engineering College, on behalf of Netaji Engineering College, that from Canada also, if you can spare some time to have more such webinars, maybe once in 3 months or 4 months. If you agree to that, we'll be extremely happy.
I would love to do that, Dr. Barman, but I really like to do something which is my core topics, which is maybe lubrication, maybe vibration, maybe packaging. Pumps, of course. Pump is my last subject. Tell me when and how, and give me a couple of months time. So I'll prepare something, and then we'll do in the same way we did today. The general topics will not help. In an interview, the students will be cross-questioned. Okay, how much do you know about that? Do you know the inside of it? What will you do when you are in this situation? So I really want to give them an insight, and they can take it home and then study it later. So I'm on it as long as you folks give me opportunity.
Thank you very much, and thank you very much, Shekhar.
I'm retired. I'm retired anyway. Put me into some job like this. If few students learn something, be benefited, that'll be great. Okay.
And thank you for this informative session. Now I pass on the mic to Argho Basu, because he will conclude it. This entire session is completed. Thank you.
Thank you so much. Thank you so much, DB sir, and thank you so much, Mr. Banerjee, for taking part in this session. And this was really invigorating. I believe the audience who have been there, they will be leaving with contentment in their heart and a lot of knowledge and the things to ponder upon. Thank you so much for being a part of this. I'd like to thank everyone who was present in this session on behalf of Netaji Subhash Engineering College, every individual who has taken part as an audience, every individual who has made this webinar possible in the first place. And I hope that we get to arrange more sessions along this line soon. And thank you so much again. Stay safe, stay connected.
Okay, take care, folks.